Hello. Outdoor Pursuits. Mr. Lawrence here, going for the record. Didn't quite make it, but I'll keep practicing. Maybe I should take up swimming. That would help my breathing. Anyway, today we are solving systems of equations by graphing. And these systems, all it's a fancy way of saying is more than one equation at a time. And what we're after the place where they cross. Okay? We're looking for the point where the equations would cross on a graph. Okay, now in today's lesson, all the equations will be linear because you don't know how to graph a nonlinear equation yet. We're going to get to that in a little bit, but we will solve systems by other methods where not all the equations are linear or none of them are. So at the point where the equations intersect, we'll say, the point where the equations intersect. So for today's example, there's going to be four of them. This will be example one, of course. We're just going to be going ahead and graphing two linear equations using one of the methods we know, slope intercept form, standard form, something like that. And we're going to try to find out the place where they cross. This is a great way to do these problems, except it's somewhat limited, and I think you'll be able to see why in a minute. So let's get down to it. I'm going to graph this blue equation here, y equals negative 2x plus 5. I know that it's in slope intercept form, right? Because the y is alone. Remember we learned that? If you haven't mastered that yet, you're going to need to come in for help because I expect you to know it already. I'm not reteaching it, but I will help you relearn it in case you were in a downslide when we taught it. All right, so my slope of this equation is going to be a negative 2. That's a fraction, negative 2 over 1. And my y-intercept, my b, is the 0.05. So I'm going to plot that point, 0, 1, 2, 3, 4, 5, right? And instead of redrawing, I'll just infinitely clone him. And then I'll go, let's see, I gotta go, oops, something happened there. Okay, go down to right 1. And from there I could go down to right 1. Remember, I could go up to positive 2 and then negative 1 in the run direction. And now I have my line, so I'm going to go ahead and draw that. 1, 2, 1. And I'm going to make him as thin as possible so I'm not confused about where he intersects the other line. Of course, I need arrowheads on there because he's not a line without the arrowheads. He's only a line segment. And my graph is looking pretty good. I guess I could have changed the color, but it's got the blue points, so I think that'll be sufficient. All right, now I'm going to graph this one. The slope is going to be 3 over 2. My y-intercept, or b, is going to be 0, negative 2. So I'm going to plot 0, negative 2 right there. Right? All right, and I'm going to infinitely clone him. Oh, wrong button. Infinite clone. And now I'm going to rise 3, 1, 2, 3, 1, 2, run 2. Ooh, look at that. I know where these lines are going to cross. Did you notice I hit it? 1, 2, 3, 1, 2. Yeah, I hit an overlapping point when I did that. So let me get my line. Guess I could use this one. I'll have one less arrowhead to do. 1, 2, 3, 2. Okay. All right. Okay, so my point of intersection where the two lines cross is right here, and that would be the solution 2, 1, the point 2, 1. That's the point at which both lines have in common. Both lines pass through the point 2, 1. That's what I'm looking for. All right, so you're thinking, hey, this is pretty easy, and it is. Let's try problem number 2 here. Let me switch to blue. Looks like my slope is 1/5. My y-intercept is 0, so it's going through the origin. So I'm going to rise 1, run 1, 2, 3, 4, 5. And I could rise 1. All right. And let me get a line going here. let's see. There we go. All right, let's see. One, two, three, four, five. Yeah, there we go. Okay, trying to make sure I do it as well as possible because if I'm off a little bit, I'm going to be confused. I want to take time and do it right. Now, equation number two, the red equation, is not in slope-intercept form. It's in standard form. And so I'm going to find the y-intercept. Remember, the y-intercept can be found by taking c and dividing by b, right? It'll be 0, that point. Well, a, b, and c are 3, 5, and negative 20. So my y-intercept is going to be the point 0, and negative 20 divided by 5 is negative 4. So 0, negative 4. So 1, 2, 3, 4. All right. Now, um, let me see here. Um, sorry, I lost my train of thought. I'm not going to go after the x-intercept because it's going to not be an integer. I'm going to go after the slope. And I remember the slope can be found by doing the negative of a over b. And so the negative of a is negative 3 and b is 5, and there's my slope. So I'm going to go down 1, 2, 3, and right 1, 2, 3, 4, 5. There's my second point. Now, to see where they cross, I'm going to go up 1, 2, 3, and back 1, 2, 3, 4, 5. Oh, look at that. Now you know I was so diligent about doing it right. Look, it's going to cross the same at a specific point. So let me do this. And all right, there we go. So the place where they're going to cross is right here. And so my solution to this system will be the point, I believe it's negative 5, negative 1. 1, 2, 3, 4, 5, 1. Now, there's a problem with this method that I alluded to earlier. So let's take a look at problem 3 and see if you can figure out what I'm talking about. All right. First equation, the blue one, is in standard form, and I see the x-intercept and the y-intercept are easy to find. I'm going to do 6 divided by 2. And then the y-intercept is going to be uh, 0, 2, right? Okay, so 3, 0, 1, 2, 3, and 0, 2, just like that. Looks like my slope is negative 2/3, up 2, back 1, 2, 3, and 1, 2, 1, 2, 3. There we go. Okay, so 1, 2, 1, 2, 3. All right. Put an arrowhead, and there we go. The red one, the red equation, is also in slope-intercept form. It looks like both the x-intercept and y-intercept are 0, which means this line is going through the origin. So I'll do the origin, and then I'll do the slope, which is the negative of a over b, and that will end up being negative 4 over negative 4, which is 1 over 1. And so it's going to go like this, right? So let me draw my line. Let me make it nice and thin so that you can see it. Maybe I'll even change the color on it. Ooh, a pretty pink color. How lovely. Just right for a person who likes manicures. Right, Gotham? All right, so looks like I'm crossing here. Now there's the problem. That's not the point 1, 1. It's a little bit off. You can see 1, 1's that little red mark right in there. See that? So I'm going to do my best to determine the x coordinate. Well, it's going to be a little bit more than 1, so I'm going to guess that it's about 1 1/10. And then the y-coordinate looks like it's about a little bit more as well. I'm going to call it 1 1/10 and then 1 1/10. There you go. There's the problem. See, I don't really know. Maybe it's really 1 1500ths and then 1 900ths. How do I know? These numbers are very close to each other. The x coordinates and y coordinates, they're very similar, but my eye can't tell the difference between 1 1/10 and 1 1500ths. Okay, or 1 1/10 and 1 900ths. I mean, this is only a penny away from that one. I don't know if you realize that. So this is the problem with solving by graphing. You don't always get a nice pretty solution where everything works out. Sometimes you have to kind of guesstimate the approximate solution. Now, in some situations in life, a guesstimation is a wonderful thing. In other situations, it requires exact precision. All right, let's try number 4 here. This will be the last one, and then we'll call it quits on this video. Looks like I'm in standard form again. Let's see here. I think I'm going to go after the x-intercept in red. Oops, I want it in red. The x-intercept. That's going to be 5, 0. And then I think the slope will be my best choice, and that'll be a positive 2/3. 1, 2, 3, 4, 5. And a slope of 2/3. 1, 2, 1, 2, 3. And so I am ready to draw. And we'll make this one, since it's in red, we'll make it a pretty pink color. Okay, and now I'll do the blue one. And this one, both the x-intercept and y-intercept seem easy. I think I'll go the x-intercept. And that'll be 6, 0. And the y-intercept will end up being 0, 7. All right, so 1, 2, 3, 4, 5, 6, 7. And then 6, 0 should be right here because that one was 5, 0. And so I'm going to do this. And look, I'm in another situation where they don't cross perfectly at an intersection of integers. So I'll tell you what, I'll make this thin so I can be as exact as possible with it. Put an arrowhead on them. I'll make them a green color. And I'll thin them out. Make sure I'm hitting that. And there we go. Okay. And let's see here. So my solution is right here. So I'm thinking that the x coordinate, it's going to be about 5 7/8, 7/10, excuse me. 5 and, oops, sorry. We're going to go with 5 and 7/10. And then the y-intercept looks like it might be about 4/10. Okay, and that's the best guess I can do. It looks like it's a little bit under a half. So I'm having to consider where they cross. Okay, that's the video for today. We're going to be solving systems by graphing. All right, Mr. Lawrence signing off. Have a good night, everybody.